The Pacific Ocean, at its narrowest reasonable crossing point, from Japan to California, spans 19,000 kilometers. If you just pictured a bridge, just a really long one, forget that image. Because once we translate this construction into money, it turns out humanity physically cannot afford it. Not because there aren't enough engineers, not because there isn't enough time, because there isn't enough money on the entire planet at once. Let's do the math. Let's start simple. Just materials. No workers, no machinery, no design costs. Just concrete and steel. The longest bridge in the world today is the Danyang-Kunshan Grand Bridge in China, 164 kilometers, which cost around $8.5 billion. Simple math. Divide by the length, multiply by 19,000 kilometers, and you get more than $980 billion. Almost $1 trillion. Just for materials, at the price of an ordinary bridge over land. But the Pacific Ocean is not land. There's no seabed at a reasonable depth, no anchor points every few hundred meters. This is open water, storms, and waves the height of several floors. The real number would be several times higher. Expert estimates for comparable megaprojects raise the complexity multiplier by a factor of 3 to 5 at minimum. That is already $3 to $5 trillion. That is more than the annual GDP of the United Kingdom. That is more than the annual GDP of France. And we haven't built a single support pillar in open ocean yet. If you've made it this far and you're already a little shocked, subscribe, because the numbers are about to get absurd. The second cost category is depth, and this is where the real nightmare begins. The average depth of the Pacific Ocean is about 4,000 meters. That's not a puddle, that's almost the height of Mount Everest, just inverted. At its deepest point, the Mariana Trench, the depth is nearly 11,000 meters. To place a bridge support at that depth, you have to solve a problem humanity has never solved at industrial scale. Building a foundation under pressure that, at the bottom of the Mariana Trench, exceeds 1,000 atmospheres. For comparison, that's roughly the weight of 50 large airplanes pressing on every square meter of surface. The most ambitious underwater engineering projects today, oil platforms, operate at depths up to 3,000 meters and cost billions of dollars each. Now imagine you need hundreds of these supports, spaced every few kilometers, at depths that exceed any existing engineering record by 2 to 3 times. A conservative estimate just for underwater foundations adds several more $1 trillion. For comparison, the entire NASA space program since its founding, including the moon landings, cost roughly $650 billion total over more than 60 years. The supports of one bridge cost more than the entire history of human space exploration. But the most expensive part isn't even the construction, it's what happens afterward. The Pacific Ocean is surrounded by what's known as the Ring of Fire, a zone where nearly 90% of all the planet's earthquakes occur. This is where tectonic plates collide, tsunamis are born, and underwater volcanoes erupt. A bridge built across this zone doesn't just sit there. It experiences micro shifts in the ground beneath its supports every single day. Every few years, an earthquake strong enough to damage the structure. Every decade or so, a tsunami capable of wiping out entire sections of the bridge. This means the bridge cannot be built once. It has to be constantly repaired, reinforced, and rebuilt. Infrastructure experts in seismically active zones estimate annual maintenance for megastructures like this at 2 to 3% of construction cost, every single year, indefinitely. At a total project cost in the range of $5 to $8 trillion, that's an annual bill of $100 to $200 billion, just to keep the bridge from falling apart. For comparison, the annual US military budget, the largest in the world, is around $850 billion. Maintaining one bridge costs a quarter of the military budget of the richest country on the planet, every year, forever. Let's add it all up. Materials and basic structure, several $1 trillion. Underwater foundations at extreme depths, several trillion more. Annual maintenance in an earthquake zone, hundreds of billions every year, indefinitely. The total initial investment lands somewhere between $8 and $12 trillion. That's more than the combined annual GDP of Germany, Japan, and the United Kingdom. That's comparable to 1/10 of the entire world's GDP in a single year. And that's not even accounting for the fact that parts of the bridge would need to be rebuilt before the rest is even finished. Humanity is technically capable of building a bridge across the Pacific Ocean. It's just that doing so would require halting almost the entire rest of the planet's economy for years. Sometimes the most interesting answer to a what-if question isn't impossible. It's technically possible, but so expensive it becomes absurd. If you want to see the next mega project that bankrupts the very idea of common sense, hit like, and I'll see you in the next video.